In last couple of videos, we talked about what is dependent variable, what is independent variable, which is the most preliminary stage of data science. And to be more precise, if you want to predict anything on top of a data, the very first keystone to understand is what is dependent variable and what is independent variable. Now, in this video, we will try to understand in depth what is linear regression. So before directly jumping into the coding, uh, if at all we have to think about what is linear regression, let's take a step backwards. And we all have studied the equation of a straight line. This we might have studied in undergrads. There is a simple equation which is y equal to mx plus c. So this equation, this is what we always try to figure out through linear regression. Where in this equation, y is what we are trying to figure out, m is the slope which it makes with the x-axis, and c is the intercept. uh, don't worry if you don't get this equation completely. You just imagine that there is an equation y equal to mx plus c. This equation represents a straight line. If we figure out this equation, we can figure out the future values based on the variables used in the equation. For example, the most basic example is if we have to predict the price of a house, there are certain factors which will be influencing the price. Let's now consider only one factor. Uh, the price of house is getting influenced by the number of rooms it has. So in an ideal scenario, the number of room increases, price will also increase. So if imagine we have a lot of data of the price and number of rooms uh, across a region, or it's or it can be a combination of different regions. Based on these two columns, if our research question asks find out the price, our price becomes dependent on the number of rooms, which is independent. Using linear regression, we will try to figure out how this number of rooms to match how, I mean, how much it is contributing towards the price. This is what actually the main theme besides linear regression. And here we have taken in account only one variable. We can take in account multiple variables which we will introduce step by step by step. Right now, let's try to figure out this problem statement with only one variable. Problem statement is something like that: we have house price and we have number of rooms, and we are trying to figure out the house price based on the number of rooms in a property. So let's jump into the coding part now. But before jumping into the coding part, if you don't understand what is dependent variable and what is independent variable, I would suggest you that you go and watch. I have uploaded a detailed video on this: what is dependent variable and what is independent variable. This is really important because this is the stepping stone in data science actually. So yeah, let's jump into the coding part. Let's try to understand linear regression through a coding example. Uh, Here, what we have done, we have created our own dataset. Uh, if you see here, I have created price of the property, then number of rooms that property contains. This I have created a manual dataset here so that it's easy to understand and decipher the result of a linear regression model. Here we have taken only 9 or 10 data points so that we put the data into model quickly and get the result out quickly also. The most important factor here is that uh, The way I have designed the data, it's like if you see here, as this price is increasing, number of rooms are also increasing in the same fashion, and we will supply the same data to our linear model, and let's see if it finds out the pattern pertaining to this data points or not. This is how actually, if you don't understand how do we create our own manual data in R, this is how we do it. Just you just have to create two columns, then pass that column into this data frame function, and it will create the function, not the data frame according to your need. Here we have created data frame. Now what what we are trying to do here is creating a linear regression model. Let's name our model as model.lm, and the function to create the linear model is lm. What we are trying to predict here is the price based on number of rooms which will be read from our data. The data name is sample.data, and once we create that model, we would like to see the summary of our created model as well. So that's how we do it. We pass into the summary function, and let's try to run it. Okay. Once we run it, this is a big chunk of result which we get here. So you don't need to break head to understand everything what's written here. The most important, first of all, the most important thing which you are going to look at is this multiple r square value. Right now it's 0.9085. What this represents is like the approximately 90% deviations in our data is perfectly explained by our model. This is in direct relation with how good our model is. The more this r square is, the better the model ideally is. I mean, there are also other factors which comes into the picture later on, but right now, as a beginner level, we will think as if the better the r square, the better the model. Also, if we look here at the coefficients, this intercept, if you see written here, it's the intercept, it's giving us 20.47, and this is the m value for rooms. uh, if you don't understand what is m value and what is intercept, again, don't worry, we will draw a graph just to interpret these values according to the result. Let's try to decipher the result which we get in summary of this model. Now let's try to put it in a more explainable format. So this is the result which we got from our the summary function. Now, as we talked about earlier, that in linear regression, what we try to do is we try to figure out the equation of a straight line, which is y equal to mx plus c, where c is the intercept, m is the slope, and y variable is what we are trying to figure out, and x is the factor which is influencing the y. So if we have to understand this equation with the result what we got using our linear regression model, this is how we decipher it. So in our case, we are trying to predict price here. So y will represent the price. Sorry, I may have to use a different color. So y here represents the price, and x here represents the variable which is going to influence our price, which in our case is rooms. Now the intercept which is the this is like where it is cutting the axis, this is going to represent by this intercept here. So this is the value which we get here, and the slope of the line, which is m, this is that value. So now our equation is complete. Y equal to mx plus c. Usually on y, by a standard, we represent what we are trying to figure out. Now if we have to rewrite this equation again, this is how we will write it. This is y which we are trying to figure out. The m is rooms, and the intercept which we get here is 108. So yeah, 108. I might have to increase the size. Yeah, 108 plus the intercept is 20.47. This is the equation which we get from our linear equation. Now how this equation plays an efficient role, you can understand it like that. In this case, we have to figure out the price. If we know the number of rooms, we just directly put it in this equation and we will get the y as an output. And the more accurate the output is, the more better eventually the model is. Similarly, we can introduce multiple factors here, and we try to put in the equation, not exactly put in the equation, we try to fine tune the equation such that with minimum number of variables included, we get the maximal accurate model. This is the most basic model which we have created using one column as an independent column, which is influencing our price as a dependent column. Now let's try to plot this data points against our linear model. But before we move towards the plotting of our data points, if we if you don't understand what this slope is or what this intercept is, you can understand it like that. This is x-axis and this is y-axis. Suppose there is a suppose there is a line. This is actually completely mathematics here. There is no I mean rocket science involved here. It's a basic 10th grade maths. Suppose there is a straight line which starts from here. So this angle which it makes here theta, this is what the slope is, tan theta. And suppose suppose you have to figure out this theta based on the number of points. Mathematically, this is how you decipher. Here there are 2 points. One point is here and another point is here. So we just find out the corresponding values. Here it will be x1, y1. For this point it will be x2, y2. So our slope, or tan theta to be more precise, tan theta, we all know that it is perpendicular by base in a right angle triangle. Suppose this is a right angle triangle and we have to find the tan theta of this angle. This will be this perpendicular by base. Same thing, same basic thing we are trying to figure out here. This will eventually make a right angle triangle if we look into more detail, and this theta here eventually is our slope. So in this case, our perpendicular will be this and base will be this. To figure out again this perpendicular, this will be this y1 minus this y2. So if we have to find the equation, this is how will be. Suppose slope m will be m equal to y1 minus y2 divided by x1 minus x2. This equation what we see here is the slope of a line. So mathematically, if you have to decipher the content of linear regression, what actually slope is, this is what it is in a more detailed and more precise way. Now let's try to represent this model which we have created here. Let's try to plot this model result and its data points using ggplot library in R. To do that, this is how we approach. Now since our model is created, what we will do, we will use ggplot. First of all, let's try to just plot the points available. So by standard, what we do, on y-axis we draw whatever we want to predict, and on x-axis we supply the variable which we think it's influencing the price eventually. In our case, we have only two columns, one is price and other one is room. So using ggplot, if you don't understand the ggplot, don't worry, we will do a separate video on how to use ggplot. In this video, just try to understand it like that. Use ggplot on this data, and on x-axis supply rooms, and on y-axis supply price in form of geometrical points. So eventually this will create a scatter plot. Let me run it. Yeah, this is the scatter plot it has created. Now again, uh, based on these data points which we see here, we have created our model, and that model is nothing but a straight line. If we want to see what that straight line is on this data point, this is how we do it. We just use the 45 function in combination with our data points, and this is how we draw it. Now right now you see this line here, this is the straight line. Now let's try to understand this graph. Yeah, okay, so this is the straight line which our linear model has given. Basically, on x-axis we are using number of rooms, and on y-axis as usual the price has been represented, and this straight line is nothing but the output of our linear regression. Now to understand the accuracy of a model, if we have to visually arrive to a conclusion, you see there are certain points which are more near to the line and certain points which are away from the line. So uh, the more the more number of points which are near to this uh, blue line, the more accurate our model is. So this can eventually be understood as, ideally our model has predicted that this is the data point, but there is a certain error I now it is here. Again, similarly for this point, ideally the point should be here, but our model, but in ideal situation the point is here. There are certain possible errors here, so we try to reduce this error as much as possible, and in this process we try to reduce it in a balanced way so that we don't lose the accuracy, and we fine tune the model as well. For example, here there are many straight lines can be possible. For example, there can be one more straight line like this. Sorry, not this is not accurate depiction of it. One more straight line can be like this, and one more straight line can be like this. But if we see, the least number of possible errors is in this line only, so we reject all these two lines and we accept this line as our final output. So if we have to go into more detail, there is more concept on understanding the SSE, SSE errors, residual errors, and if statics, which we will talk in future. But this is the most basic linear regression, what it is, how it is connected. I mean, how finding equation of a straight line can be done using these supplied variables from our result. I hope you understood it completely.